This is how to wire a float switch to a pump. The finished diagram, right here on screen. A tank, a float that rises with the water, a float switch, a relay, and the pump. When the level crosses the line, the pump switches itself. Nobody's standing there watching it. It looks like a lot of wire. It is not. Let me rewind and build it from nothing so every connection makes sense, and you know exactly which two wires decide when your pump turns on. Start with the star of the show, the float switch. It is nothing more than a switch that senses water level. A float rides on the surface of the water, and as the level rises or falls, the float moves, and that movement flips a switch inside. There are two common shapes. A tethered, or tilt, float hangs on a cable and tips over as the water lifts it. A vertical float slides up and down a stem. Either way, the job is the same. Turn a water level into an on or an off. And like any switch, it has an action. Normally open, which closes as the float lifts. Or normally closed, which opens as the float lifts. Hold on to that. The action is what makes it fill a tank, or empty one. Now, the wiring, and there are really only two cases. The first is the simple one, a small pump inside the float switch's own current rating. Check the float switch. It is stamped with a maximum amp rating. If your pump draws less than that, you wire the float switch straight in series with the pump's live wire. Live comes in through the float switch, out to the pump, and neutral back. When the float closes the switch, power flows and the pump runs. When it opens, the pump stops. The float switch is doing the switching directly. Few parts, and perfect for small drainage or transfer pump. Quick note before we go bigger. Every diagram in this video is drawn in a free editor that runs right in your browser, CircuitDiagramMaker.app. No install, no sign up. Open it in a second tab, drop in a tank, a float switch, and a pump, and follow along. Here is the second case, a bigger pump. A borehole pump, a large sump pump, anything drawing more current than that little float switch is rated for. Wire a heavy motor straight through the float switch, and you will burn its contacts out, arcing, welding, and an early failure. So we stop the float switch from carrying the motor current at all. Instead, the float switch only switches a coil, the coil of a relay, or for a real motor, a contactor. That is a tiny current. The contactor then does the heavy lifting. Its big contacts carry the full pump current, and it is safely rated for the job. Low current float switches the coil. The contactor switches the pump. That one idea protects your float switch and handles any size of motor. Now the part everyone gets backwards, the logic. Does the pump run when the water is high or when it is low? It depends entirely on the job, and you invert the float switch to match. In a sump or a drain, a pit that must not overflow, you want the pump on when the water is high to pump it out and off when it is low. In a tank you're filling, a reservoir, a header tank, you want the exact opposite. Pump on when the water is low to fill it up and off when it is full. Same float switch, opposite action. You pick a normally open or a normally closed float, or you flip it over so that crossing the level closes the circuit in one case and opens in the other. Decide first, am I emptying or filling? There is one more trap with a single float, rapid cycling. Right at the switching level, a ripple on the surface makes the float bob on, off, and that hammering will kill a pump. The fix is 2 levels, not 1. Use a float with a wide swing or 2 separate floats, a high one and a low one. The pump turns on when the water reaches the high float, and it does not turn off again until the water drops all the way down to the low float. That gap between the 2 levels is called hysteresis, and it lets the pump run a proper cycle instead of chattering itself to death. And one safety add-on worth knowing, dry run protection. A pump that runs with no water can overheat and destroy its seals in minutes. So on a supply tank, you add a low-level float that cuts the pump the moment the water drops too far before it can ever run dry. It is a small float and one more contact in series with the coil. Cheap insurance for an expensive pump. Let's put it all together on one sheet. Supply comes in, live, and neutral. The float switch in the tank senses the level and switches the contactor coil. The contactor closes its main contacts, and sends full power out to the pump. The tank, the float, the switch, the coil, the contactor, the pump, every part on one clean diagram. You can follow the current from the wall all the way to the motor with nothing hidden. So that is how to wire a float switch to a pump. A float switch turns a water level into an on or an off. Small pump? Wire the float straight in series with the live. Big pump? The float switches a relay or contactor coil, and the contactor carries the motor. Emptying a sump means pump on when high. Filling a tank means pump on when low, so invert the float to match. Add 2 levels for hysteresis and a low-level float for dry run protection. Open the free editor, drop in a tank and a pump, and wire your own. The link is in the description. Subscribe for a new wiring diagram explained every week, and I will see you in the next one.